Welcome back, guys. In today's video, we're going to solve another question about 2D equilibrium, and we're going to use again the 2D shortcut that we covered in previous videos. I'm going to put the link for videos in the description. You guys can go over the concept of 2D shortcut that we have for solving the moment questions. So we have a hand truck that is used to move two kegs. We know the mass of each keg is 40 kilogram, and we neglect the mass of the hand truck. In the A part, we need to determine the vertical force P that should be applied to the handle in order to maintain the equilibrium, and we know the alpha is 35 degrees. And in the B part, we need to find the corresponding reaction at each of the two wheels. So we actually have two wheels, but since we are looking at the 2D picture, we're only seeing one, but we're gonna show it for two wheels in our free body diagram. So again, we're gonna start with the free body diagram as the first step, and let's go over the forces that we have in here. So there's 2 point G1 and G2, which is the center of gravity for the two kegs. And if we want to show the force, we'll have this one, let's call it W. And since they have the same mass, they will have the same weight too. So I'm going to show both of them with W. And the other force that we have is the reaction at the wheel. So as I was mentioning, there are two wheels. So let's consider the force in each wheel B. And since we have two, we're gonna put a 2B in here. Then at the end, we can find the reaction at each wheel. That's pretty much what we have for the free body diagram. We have the force P and the two weight and the reaction at the wheel. So now that we have this, we can move on to our equilibrium equations. So since we are in equilibrium condition, we'll have the sum of all forces equals 0, and the same for the moments. That would be 0 about any point that we consider. I'm just gonna name these points. So the center of the wheel, let's call it B, and where the force P is applying, we're gonna call it A. So we know this angle here is, from the question, 35 degrees. And I think that's it. Let's move on with the moment equations that we have. So we're gonna consider counterclockwise, positive, and let's figure out which point we can find a moment about. So the unknown that we have in here are P and B. Let's just cancel out one of the moments, but by going to the point B. So if we find a moment about point B, we can get rid of the reaction at the wheel. So we'll end up with P and W. So let's see what we have for the moment about point B. Let's start with the point G1 and the moment that this force is making. So in order to use our 2D shortcut, we'll see that this moment would be counterclockwise, as I'm showing like that. The force W at G1 is going to make a counterclockwise force in about point B, so it will be positive, and for that we need the force, which is W times the distance, and we're looking for the vertical distance of these two, and that would be this distance in here, which I'm gonna show it with A1. So we'll have W times A1. I'm gonna find these distances later, and let's see what else do we have. So the other moment that we have will be the moment of the weight acting on G2. And if we look at that, that moment is gonna make a clockwise moment, which will be negative, and the distance again will be this distance, which we need to figure out. Let's call this one A2. So again, we have force times the distance, and since it's a vertical distance, we just need to multiply the amount of each. So that's what we have for these two weights. There's also the force P, and let's figure out the direction first. I'm gonna highlight it in red. So going from point P about B, we'll see the moment will be in this direction, which is counterclockwise. So we will have a positive moment, and we need to figure out the distance, and the distance here this time will be this distance that I'm showing in here. So if I continue the line of action of force P, this will be our distance that we are looking for, which would be the vertical distance. And let's call it B, and that's all the moments that we have about point B. Well, let's figure out the unknowns that we have in here. We need to figure out W, which they're all known. So we know the mass of the each keg is 40 kilograms, so we simply have mass times acceleration of gravity, which is 40 times 9.81, which is the acceleration of gravity, meter per square second, and this will be kilogram. And from here we get 392.40 Newton, the weight of each keg. So W is known. Let's figure out what do we have for A1. So for A1, here's the distance that we have, and we know what's this angle, or we can figure out this angle based on the information that we have for alpha. So if I'm gonna highlight it in yellow. If this angle is 35, we'll have the same angle for this one. So this one would be 35 as well. And then how do we find this? So whenever we have two angles like that each side of them are perpendicular to the other one, that doesn't look pretty at all. Let's try one more time. So we have this, and we'll have, so when we have each side of, so we're talking about these two angles. When we have right angle for each of these two, so we have one side of the angle perpendicular, so this side is perpendicular to this side, and we have the same thing for the other one. This side is perpendicular in this side. So in these scenarios, these two angles that I'm showing are the same. And if we look at here, we'll see the same scenario. So I'm gonna show it in red. This is actually a very good trick for finding the angles in most of these questions. So we'll have this angle here perpendicular to this, and we have this one perpendicular to this. So these two are the same. So we can use this trick to find the angles, and it works perfectly for finding the angles in these questions. So having said that, we know this angle here is alpha 2. So now that we need to find the A1 and A2 and B for our moment equation, I'm going to draw another free body diagram, then we can see these distances better. So we'll have the wheel on here that and we have the weight of the first brake applying in here, and what we are interested in is this distance which we called it A1. If we draw something like this, we can find the A1 would be simply what we have in green part in here, which we also have all the angles. So we have this one alpha and this angle alpha. So from the question, we know this is 300 millimeter, and we have 80 millimeter in here. So finding these, so we have this right triangle in here that we can see that for finding the green part, 300 times sine of alpha would give us the green part in there. And if we want to find this, what I'm showing in the red in here, we see that 80 times cosine of alpha would be that distance, minus 80 times cosine of alpha, we get that part. So what we have, we simply are subtracting the green part, which is what we have actually in here, and the red part is what we found in here. And then if we subtract these two, we can find what we're interested, which is A1. So this is how we find the A1. Let's move on to A2. So for A2, we have another force. If we continue this, we have W2 applying in here, and let's call this A2. And for A2, what we are interested also, we know from here to here is 350 millimeter. So what we have in here, if we look at the triangle that I'm showing in here in yellow, we can find this part easily by 80 plus 350 cosine of alpha. And if we want to find what we found in the previous part, this part, we can have what we figure out in the previous part, which was 300 times sine of alpha. And if we subtract these two from each other, we'll get what we call A2. And that's how we can find the A2. And the last part that we need is what we found, what we call B. So if we continue, let's say our P is applying somewhere in here. and we consider this distance from the wheel to here B. And simply if we look at this triangle here, here, and we know this angle is alpha, and we can find this. So from the question, we know this part is 500 millimeter. So for finding the B, we simply have the hypotenuse of the green right triangle, and this would be a right angle. So we have 80 plus 350 plus 500. And this time, if we do the cosine of alpha, we'll get our B. So now that we have this, everything's good, and we just need to calculate each of these three. And we know that the alpha is 35 degrees, so I'm just going to clean up, and we can calculate all the unknowns that we have for this question. So simply, we're just going to consider alpha 350 degrees from the question, and if we do that, we can get A1 106. We can get A1 106.541 millimeter. For A2, we'll have 180.162 millimeter, and for B, we'll have 761.81 millimeter. And if we just put the amount that we found in here in the moment equation, which I'm showing with the star, we have W, which is 392.40 times A1, which is 106.541. Minus, again, we have W 392.40 times A2, which is 180.162. And we have P as the unknown, but we know B is 761.81 equals 0. We don't need to do the unit conversion for the millimeter because it will be canceled out anyway. So it won't make any difference if we divide any of these by 1000 to get meter. And the P eventually will be 37.921 Newton. We found one of the unknowns that the question is asking. The other unknown that we need to find is the reaction at wheels. So again, since there are two wheels, we call it we named it 2B. Then we can find the reaction in each wheel. So if we do our Fy, we simply have the 2B minus the weight of two kegs. So we'll have 2 times the weight of each, and we'll have the force P. And that's everything we have for this equation. So 2B will be 2 times the weight, which was 392.40, and we found P 37.921. And from here we can find the reaction at each wheel, which will be 373 Newton. And that would be the final answer for this question.